I'm back with episode 55 of the InfoSec and OSINT show. As you know, the show is about sharing practical tips of what works and what doesn't in cybersecurity. Essentially, we try to turn our guest wisdom into practical tips you can use to grow in your career. I have a great conversation today with Charlie Belmer. Charlie is a privacy and security engineer over at DuckDuckGo, where he focuses on protecting users against various fingerprinting techniques, which means he helps us stop sites from tracking us. My three main takeaways were: 1, how to find NoSQL injection and how it differs from regular SQL injection; 2, why privacy still matters; and 3, how cookieless tracking works and some of the frightening techniques used. All right, let's dive into our conversation.
So what's the difference between normal SQL injection and NoSQL injection?
Yeah, it's a good question. So typical SQL injection, it's been around for a very long time, and you try to append the query with something that you've injected, and then try to get the database to respond with what you want. The same thing is generally true with NoSQL injection, but the difference between NoSQL and SQL is pretty significant. So SQL has built up over time a lot of defenses. For instance, parameterized queries is just sort of the way to defend against SQL injection, or you can use a framework that defends against it. And you don't have to worry too much. It's a structured query language. It has well-defined properties, and it's relatively easy to defend against. Once you start looking at NoSQL, the game changes, because first, every NoSQL database may have its own language or its own support for languages. Many NoSQL databases directly execute JavaScript within them. So if you can get some JavaScript in there, and as we know, there's tons of ways to inject JavaScript in lots of different ways, and it's really hard to filter out JavaScript. So if you can get any sort of JavaScript to get towards the NoSQL database, you may be able to execute it. And then they also, instead of using a SQL or a structured query, they use JSON in a lot of cases to run your queries. And it's really hard to figure out what's a valid JSON component. It looks like a string, but it might be interpreted as not a string once it gets the database engine. So it's a lot harder to filter, and there's a lot more types of NoSQL databases out there. So the way you inject it is different, and the way you defend against it is different. And the nice thing is, from an attacker perspective, is it's a little bit under-researched. So when I go out and I look around at the web, you see a lot of discussion about SQL injection, a lot of people worried about it. You don't see the same thing in NoSQL injection. In fact, you'll see the opposite, where you go to Stack Overflow and someone says, hey, I'm kind of worried about NoSQL injection. Is that possible? And most of the responses are just sort of saying, don't worry about it. You're doing fine. You're good, but there's clearly an injection vector. And there's also not a lot of tooling in this space. So it's sometimes under-researched, and I think there's sort of a large iceberg of NoSQL injectability that's out across the web today.
Cool. So can you tell us a bit about your tool and why you wrote it?
Yeah, so my tool is called NoSQL. It's fully open source. So my goal was to create a tool that's as useful as SQL Map, which is sort of the go-to tool for SQL injection. NoSQL is not nearly as capable as that. It's a newer tool. All it does today is it scans a web page for any injectable properties and attempts to inject a variety of NoSQL injections. So it does a variety of different attacks. It looks for simple, it tries to inject things like a single quote and then sees if it gets back an error message. So pretty much the most basic tests. And then it does blind Boolean injection, where it'll try to inject a bunch of true values, a bunch of false values, and try to make the query complete so that they both execute and determine if the page is different. It does timing attacks, where it'll try to determine if the page, catches any errors that come through. Can it still detect it based on, the timing difference in the database? And then it returns all of those query strings back to the user. It's fully CLI based, so command line based, and anyone can automate it pretty easily, integrate it into your workflow. There are additional tools out there for NoSQL injection. And the reason that I really wrote this tool is when I was researching NoSQL injection just for my own testing purposes, I didn't find any other tool on the market, whether paid or free, that really I could find SQL injection, even for like toy NoSQL injections that were made up. There's a lot of labs out there where you can try to find NoSQL injection or learn about NoSQL injection. And I was having trouble finding a tool that would automatically detect it on those sort of toy examples. So if I can't find it on like a very simplified example for learning, I doubt it's going to be able to find it in a real world scenario that may have additional defenses. So that's why I wrote the tool. I wanted to have a very simple command line, tool that's easily automatable, that I can use in my workflow, and that's robust, that actually catches NoSQL injections. And it's been, I think, pretty successful. I've already heard of a couple of people that have contacted me, letting me know that they found bug bounties using my tools on some major sites. They found NoSQL injection, and they were able to detect it, and it was the only tool they used that found it. So that excites me, and I'm hoping that we'll hear more of those kinds of stories going forward.
Well, so in terms of usage, can you pipe in multiple requests to it? How would you get like an entire session log tested at the moment?
Yeah, so today I don't offer like the session log or running through a whole session. So it's just page by page. So it's not automated in that way yet. You could pretty easily probably write a tool to just pass in a bunch of requests and then run it on each request. But that's sort of in my backlog, is being able to run against, for instance, like a Burp Suite log or another kind of log of all the different requests you want to run, and then have it run it sequentially and give you a full report. So right now it's just a particular target that you specify, and it'll go out and test that an individual target. But yeah, so that's on the roadmap. It's still kind of early days with the tool, I'll say. It's very focused on finding as many injections as possible with minimal false positives before anything else.
Okay, and then it won't do any data extraction. It will just tell you that there is an injection point.
That's right. So it'll point out where the injection happened and what the successful injections were. So it'll tell you if it's, for instance, a Boolean injection, what did it use to get a true value and what did it use to get a false value? And then you can replicate that. It doesn't, unfortunately, do data extraction yet. It's been on my roadmap for a while. Every time I start implementing it, I find additional ways to detect new NoSQL injection types or like get around defenses. So I end up going back and implementing detection first, because really the primary use case for me right now is detecting accurately issues in a website. And then eventually I definitely want to get to extraction of data and automate the extraction, particularly in the cases where it's difficult, like in a timing attack, where it's difficult to automate. I mean, it's a fair amount of work to automate that, but you may want to just have it done automatically for you.
Yeah, definitely makes things simpler. Which NoSQL databases are supported?
So today it's mostly Mongo. So I prioritize MongoDB. It does support other ones like DynamoDB and Redis to a lesser extent, but I haven't focused on them yet. So there are plenty of injections in the other NoSQL spaces that are popular, such as Dynamo, but I haven't focused on them yet. So once I am able to focus on them, I do plan to add additional support for them based on their popularity. So I sort of go down the popularity index of the NoSQL databases, and I plan to add support for each one as I get there.
Okay, fair enough. Let's talk a bit about proxies. You had a recent blog post comparing, I think it was a man-in-the-middle proxy.
Yep.
Burp and Zap. Tell us. I was familiar with Zap and Burp. Not familiar with man-in-the-middle proxy. Can you tell us a bit about that?
Sure. So I'm man-in-the-middle proxy is pretty cool. I found it when I was looking at different open source proxies that you can use for pen testing. It has a really nice command line interface, and I'm a big fan of CLI tools, if you haven't noticed from my discussion and why I wrote my NoSQL tool. So if you go take a look at Minim Proxy, everything can be done on the CLI. I think they now have a web interface, which I haven't used. I've just used the CLI. And it's nice if you are familiar with Vim or other Vim text bindings and you're good with a keyboard, because you can quickly navigate through requests. And with a couple of key presses, you can do things that if you're using a visual tool like Burp or Zap, you might have to click on a few buttons and then switch from keyboard to mouse to actually do what you want to do. And then you can also record and replay things very quickly in Minim Proxy. In general, Burp is still my go-to tool. So whenever I'm doing a pen test, I pretty much always start in Burp. I've been trying to use Minim Proxy more because I like that it's fully open source. I like that there's a community of module developers that also create open source. I'm a fan of Python, and all the modules are in Python. So it fits me nicely. It doesn't quite match Burp when it comes to like professional product usage, but I do like it. So especially when I'm trying to blog or do some research, I've been trying to use that instead of showing Burp. In particular, there's a lot of people I talk to who they may not work for a company that's going to buy them a Burp license. And so it's nice to offer an alternative that is free and open source. They can get their hands dirty and have a fully featured tool. Zap is similar. It's also a great product. I'm not sure that I would say that one of them 100% dominates over the other two. I use each of them depending on the use case. There are times when Zap is the leader And I remember there was a while where really if I was doing like WebSocket testing, I think Zap was the way to go because it had the best WebSocket testing capabilities out of the tools that I would use. That's no longer true, but for a period of time, Zap was the one to use for WebSockets. So those different scenarios can occur, and then you just have to make sure that you pick the right tool for the testing you're trying to do.
What kind of modules are available?
For Minim Proxy, mostly the ones that I've used have been around like modifying attacks or injecting like payloads that are well known. Automating things. It's similar to Burp Intruder, where you can go through and say, run against this text list of values I want to inject into a particular parameter. There's a wide number, but I'm not the person to say, what all of them are out there. You can go out to their website and they have an index of modules.
Now, you mentioned modules written in Python. You're a big fan. Why did you write NoSQL in Go?
So yeah, that's a fair question. Yeah, I like Python for a lot of stuff, but Python also can be slow, and Python is not the most. It's gotten better, I'll say, recently on like how you parallelize your processes. So if you want a multi-process tool, Python has gotten better, but Go is really really good at having really fast requests that you can parallelize. It's actually like a first class feature of Go is doing a parallel request. And of course, when you're doing a whole bunch of HTTP requests, the biggest bottleneck is going to be your network. So you want to parallelize that as much as possible. The other thing with Python tools, which is difficult, and you see this with other languages like JavaScript, is it's difficult to compile it into a binary that someone can just download and execute, and it can be less portable. So sometimes when doing a pen test, you end up on a network and you don't necessarily want to install Python with a version dependency and then a bunch of dependencies you have to go download and install somewhere in a virtual environment and just set all that up for a particular test or on someone else's machine. It's much easier if you can just pull in the right binary, deploy the binary, and then execute the binary. So Go has great support for binaries and cross-compilation for a variety of architectures. So those are really the two things, the ability to create a binary that works just on different architectures and the ability to parallelize requests. Really made Go a good choice here.
All right, makes sense. All right, let's change gears and talk a bit about privacy. So you're an engineer at DuckDuckGo. How do you think about privacy?
Yeah, privacy is pretty central to how I think about my time whenever I'm online. Is how can I be observed and how can I defend myself from being observed? Pretty much everything in our life these days is trying to monitor us in a variety of ways and extract data. So in the early days of the web, it was not so much the case. People might say, oh, this IP address is coming from this general location, and we might want to track that IP address to figure out like if they're attacking our website. But nowadays, it's become much more critical for companies to figure out who you are, how you use your device, what you do on your devices. And there's a lot of companies that their sole focus is trying to figure out who is using a particular device at a particular time, how they're using it, and what their interests are, and then to extrapolate from that other information about the individual, and then to use that for a variety of purposes. In the most cases, it's as simple as trying to sell you more things. So it typically is used in advertising. But we've seen in the US and other countries more and more using that data to try to influence political decisions or create unrest. And that's a very sort of nefarious use of personal data. And the more personal data that a group has on an individual, the more likely they are to be able to make those kind of inferences correctly and figure out how to influence somebody in a way they might not want if they knew what was going on. So privacy is defending against all that stuff. Advertisers knowing too much about you, governments knowing too much about you, people that want to influence you to do things you might not want to do knowing too much about you.
All right, so what are the DuckDuckGo privacy features that help us protect against that?
Sure. So DuckDuckGo, first, our primary product is a search engine. If you go to Google, they're tracking all your search history and they know what you search for. And what you search for is pretty private. So our search engine, we don't track any of that. So whatever you search, we don't keep any information about the individual who searches with the query. And then if you use our desktop products, like our extension or our mobile products, our mobile browser, we additionally will follow you around the web. Using our browser, we block all known trackers. So we have a tool that scans the web on a regular basis, looking for companies that are attempting to track on different websites. And then we include those in a list.
By tracking, you mean like just putting cookies or?
It could be cookies. Yeah, so cookies are a common way of tracking. So third-party cookies like advertising cookies. So a site that advertises may put an advertising cookie on your browser, and the next time you visit a site that embeds that same advertiser, they will get those cookies, so they'll know you visited site A and visited site B, and maybe what ads you saw on each site, and then they can connect that back to if you click on an ad, whether you clicked. So advertising cookies and similar third-party cookies are definitely one way, and we block a lot of third-party cookies from advertisers. Cookies have been starting to be blocked by the major browsers. So Safari and Firefox have started to roll out blocking third-party cookies and expiring first-party cookies more aggressively. And first-party here refers to when a site is setting its own cookies, that would be first-party. If a site says, hey, I want to include Google and Facebook on my site, Google and Facebook may also include cookies when you visit that site. Those would be third-party cookies because you're not visiting Facebook or Google, you're visiting some other site, but they're including some Facebook and Google content. So yes, blocking third and first party cookies is important, but what's becoming more and more prevalent is this concept of fingerprinting, which is essentially cookieless tracking. The browser and particularly mobile devices include a lot of information that are unique to you. This can be used for both good purposes like anti-fraud and not so good purposes like figuring out who you are no matter what you do on your device. So there's some demos out there where you can, for anti-fraud, around trying to figure out if you're the person that you claim you are based on how you type. So asking a user to type in their username and password gives enough fidelity to have something like 99.9% confidence of who you are as a person, just based on how you type as captured by JavaScript running in a website. So if anyone can...
What are the factors by how quick you type, or what is it looking at?
It's based on, I'm not exactly sure what the algorithm is there, but essentially it's based on how you hit the keys. So that there's like key timing information that you can get from JavaScript. So like, oh, I pressed the Z key as the first letter of my password, and I pressed it, with a certain speed. And then the next key I hit was, let's say, like an L key, and that took me, 1/10 of a second, for instance. And then I hit the K key, and it was, less, like 1/100th of a second. So they can predict basically, like, are you a touch typist? Are you a point and click typist? And then how you hit those keys. And the speed between the different keys, I guess, tells a lot about you. But I don't know the specific algorithms there. I just know that it's apparently pretty high confidence. We did some internal testing where we had different people try to trick the system, and we couldn't do it. So it was very effective at identifying an individual, and no one else came close to being identified as that individual, just typing a couple of words. So that's how effective just getting key press information is. But key press is only one of more than 100 different fingerprint vectors that can be used. So we don't defend against all of these. We would like to defend against all of these different ones. Another one is things like screen size and how fast the computer you're on can draw a rectangle or other images that are never shown to the user, but they're being drawn, behind the scenes, and then it's being seen. How is this drawn? What kind of colors were used? What does the browser support? All of these things are pretty unique to your machine, and in some cases unique to you as an individual. And combined, they create a relatively stable fingerprint of you as a person. So if you have 3 different computers in your home and you move between them, a website may be able to figure out when you're using which computer, and that's just one more piece of information they can get, as well as figure out your browsing history if they're able to figure out on each website you visit that you're there and it's you who's visiting. So all these things together, along with other things that you probably don't, like most browsers don't think that much about, but your IP address that you're broadcasting on every site you visit, your user agent string, which is a combination of your operating system and the browser version that you're using, as well as things like the language that you prefer. All of these things add together to create a very stable fingerprint. So the DuckDuckGo product suite, we seek to disrupt that fingerprint in a variety of ways. Some of those things we are still researching to try to figure out how do we prevent it without breaking sites. So I mentioned that one way to fingerprint someone is to look at how does a rectangle appear or a triangle appear. If you draw it and you rotate it and you do some other operations on it, it's different. For each computer, it might be slightly different. So it tells you a lot about the hardware.
Is it specific to a make and model computer or specific to the individual computer?
So it can be as specific as the individual computer. So the whole idea is to figure out like bits of entropy. So for all these different things that I'm mentioning, how much entropy is added to how much confidence is added, how much difference is it? So a low entropy might be, it can differentiate you between like several hundreds of thousands of individuals, might be relatively low entropy. Very high entropy would be, it's specific to you. So the keyboard pressing is very specific. It's high entropy. Things like drawing a canvas is also relatively high entropy because it's everything to do with your computer. So if you have installed a lot of software that runs in the background, and so your system is somewhat loaded all the time, with a lot of processes running, and so there's less process space available, that may influence how fast it draws the rectangles in a relatively stable way. And the same thing with your graphics card, your drivers that you have, the operating system and version that you're on. All these things influence how it gets drawn. Pretty much every piece that might interact with the speed and how things are displayed on your screen, like the color profiles, all of that factors into something like a canvas drawing. But again, that's not enough confidence to identify you uniquely. It's just one piece. But if you combine that with things like audio data, what happens when your computer generates sort of a random audio sequence, as well as the languages you speak and the location you're in based on your IP address, and the version of the browser that you're on. And Chrome, for instance, sends like the build ID, which is pretty specific. So all these things combine, and the EFF, the Electronic Freedom, I'm forgetting what their name, but the EFF, they have a great tool that'll show you, basically your fingerprint and which pieces are unique to you and more unique. And so anyway, so our tools, we work really hard to try to stop as much of that as possible. But Canvas in particular, if you think about it, like I said, it's high entropy. It's pretty specific. It's a good way to identify individuals, but it's also used for a lot of things. Like if you use the UML drawings, that might use Canvas. If you want to play a game in your browser, that probably uses Canvas. If you're doing a screen share, it's probably using Canvas. Those are valid use cases that are very hard. It's hard to disrupt canvas drawing without also breaking those use cases that a person wants to do. So a big challenge on the privacy side is how do you disrupt these sort of nefarious uses of the technology while still allowing full use in the way that users would like to, like playing games, for instance.
That's quite frightening. Is there a...
Yeah, it's scary.
Is there a single or like resource if you wanted to learn more about all the various ways that you can be fingerprinted? Any suggestions when we do learn more about that?
Yeah, there's a site called Cover Your Tracks. I think that's the EFF site, which is a good starting point. There's PhD papers out there that will go very specific into like particular tracking vectors that can be used but may not be seen in the wild, and different tracking vendors that sell this technology to companies. They all have their own, sort of secret algorithms. So state of the art, it's hard to figure out what's going on state of the art, because some of the more interesting techniques are discussed, but they're not actually in use because they may slow down the browser in a noticeable way, but they could become in use in the next 5 or 10 years. But yeah, Cover Your Tracks is a good place to start. I think they show 30 or 40 of these different tracking components. If you want to get a feel for how stable it can be, take your favorite privacy tools, go out, look for Fingerprint JS2, it's an open source library, which the open source library is pretty naive about how they do fingerprints. But they have a commercial offering, which is not naive, and they have a demo. So you can actually go out. And if you're like me and you use a VPN and you use a lot of these privacy tools, you may go to their demo. And even if you do something like change your IP address and use a new private window with some different privacy tools, they'll probably still say you're this person. And they'll know after just 1 or 2 refreshes of the page. And you can break it, but you'll often break it only if you make your web browsing experience degraded. For instance, by not allowing JavaScript to run in certain contexts, or turning off things like Canvas or audio, or changing your user agent, which may prevent you from logging into bank sites and other places that will think you're a bot instead of a person. So there's trade-offs there, and it's increasingly hard to protect yourself without making those trade-offs.
All right, so now that you've sufficiently frightened us, how do we protect ourselves?
Yeah, so definitely use services like DuckDuckGo, obviously, because I work for them, and we do a lot of really great work in this space. But really, it's behavioral is the first thing that you can do. So most of these companies that are trying to track you, they're not that unknown. They're companies like Facebook, and if you think about all the different ways that Facebook can track you, it's kind of scary. Not only when you go to their site do they have a lot of personal information about you and what you do on their site, but they're embedded all across the web. I was looking recently to see what percentage of the web uses Facebook, and I found roughly 15% of the web has Facebook embedded on their homepages. So 50% of the web may not sound like a lot, but that is hundreds of thousands of pages. that have embedded Facebook. And every time you visit one of those pages, Facebook gets notified that you are visiting, and then Facebook is executing Facebook's JavaScript code on your browser and figuring out more about you and maybe how you're using the site.
Even if you don't have a Facebook account.
Even if you don't have a Facebook account. Yeah. So they may not say this is, Charlie who's visiting, but if I don't have a Facebook account, they may say, hey, we think this is some guy named Charlie based on this profile and the fact that he has in this location and, there's someone named Charlie in that place. Like they have these shadow profiles that they generate based on friend groups and people that you can tag people and photos that don't have a Facebook account. So I don't know how much they know there because that's all proprietary for Facebook, but there's been a lot of articles about shadow profiles and Facebook sort of tracking individuals. And then Google, of course, is sort of the behemoth in this space. So they're on, I think, even if you only look at things like, Google Ads, Google Analytics, I'm trying to think of like the reCAPTCHA is what I was trying to think of. So reCAPTCHA is a Google property, which also runs a bunch of weird stuff on your browser. And a ton of sites embed some version of reCAPTCHA for anti-fraud. They embed ads through AdWords. Google is the biggest ad provider. And then individuals don't think of Google as being a social company, but of course, Google has a lot of social aspects. Like Gmail is a huge provider of email. And if you read the terms there, they, of course, are able to analyze all your email incoming and outgoing. And I have a Gmail account. I was like, back when they were only doing beta invites, like invite only, I got a beta invite. And so I've had that Gmail account forever. It was my primary account for a while. Several years ago, I said I have to de-Googleize myself. I moved away onto Proton Mail. There's other privacy providers. But if you think about all the services that you use and pay for, which of those really respect your privacy and which ones don't, is a good way to start removing some of this data from the public sphere and keeping it to yourself. And then thinking about what kind of privacy trade-offs you're willing to make and installing some of those extensions in your browsers, such as the DuckDuckGo extension. And there's other ones like uBlock, Origin, and I use like the Privacy Badger from EFF. There's a variety of these. I go all the way. Personally, I use NoScript, which disables all JavaScript until I enable it. That makes browsing quite painful, but it definitely protects me from any of these things that I'm talking about that require JavaScript execution. But some sites won't load or they won't work at all. So you have to be prepared for the difficulties. But it goes more. I mean, if like I use Spotify collects a bunch of data about me. I don't like that. So I'd love to have alternatives for things like Spotify for music streaming. Any of these products that you use, think about how does it work and is it collecting data? And it's unfortunately not an easy solution. You have to really spend time thinking about it and caring about it.
Have you found an alternative to Spotify?
I have not, but yeah, it would be nice. So if you have ideas.
All right, let's talk a bit about getting into InfoSec from a, say, college standpoint. Do you have any resources? How do you suggest somebody pivots into a career in InfoSec?
Definitely. So, my background, I went to college, I did computer science, and then I worked roughly 8 to 10 years in programming roles and project management roles and sysadmin roles before I moved into InfoSec. That was a really great background for me because it gave me a totally different perspective on like what it takes to be successful in InfoSec, and a lot of those skills directly translate. When you're in college, there's a variety of programs that feed into the InfoSec pipeline. I used to do college recruiting for individuals, and I would see students that would come from computer science backgrounds. More and more universities are offering a security-focused degree. Some of those have varying quality. So the key that I've always told students who are thinking about taking the InfoSec-specific degree or sometimes a postgraduate, like a master's degree or further, is does it really teach strong security and technical skills, or does it teach, is it very like high level and it doesn't really teach you how things work? Because if you want to go into security, I think it's critical that you understand at a deep level how things work. Most security issues that we see is all taking things how they're supposed to work and just tweaking them a little bit so they don't work how it's expected. And that creates a security vulnerability. And some of the most interesting security vulnerabilities are things like, messing up how a processor works or messing up how the memory in the computer works. Or when we're talking about NoSQL, it's using NoSQL operators in a way that the website owner wasn't expecting. So understanding how this works at a deep level is really the key to I think, being successful in InfoSec, especially early career. So I'd say look at the program you're in, make sure that it's teaching you those deep skill sets. And if they're not, then ask your professors to teach you those things, or take the classes that will teach those things. They may be in the computer science department, they may be in an IT department, but all of those can offer good guidelines. And then, as in most careers, the technical skills are only one piece, but a much bigger piece is, are you easy to work with? Can you communicate well? Do you write well? And can you explain to people what you did and why you did it? And can you take what someone else did and apply it in your own case? So are you pretty easy to work with, and can you pick up new things and learn well? Those are all critical skills.
Good advice. All right. And to close up, let's talk a bit about cloud security.
Sure.
Between Azure and AWS, is there one that's easier to secure than the other? What are your thoughts? Are there any top tips, easy wins that people can do to get their networks in order?
Yeah, cloud security is tough. I'll say cloud security is challenging just for a lot of different reasons. Between Azure and AWS, and I've used both and I've worked on securing both, I tend to prefer Azure. I think that they have a better security model baseline. So AWS, there's a lot of tools you can use, but the problem is that there's a lot of tools you can use. So AWS offers things like security groups, which are great, but then you can also have all these security products and permission groups, and you can have these, you can have a user with different permissions that can bypass different things. And it's very difficult to look at an asset in AWS and say, what is the risk of this asset, without looking at all these other places, which I think is challenging. In Azure, it's a little bit simpler to figure out, like, what is the permissible configuration for this group of assets, because they have a very nice security model around groups of assets that AWS lacks. In AWS, I spent a lot of time building up a model. They have a service called config, where you can basically write rules for what is allowable configurations for a particular asset type. But writing those rules is difficult, and getting them deployed is difficult. And then there's a lot of nuance to it. So just trying to write rules for permissible configurations for a particular type of asset, like your server or your load balancer, was very challenging. And in Azure, I haven't had the same issue, where it's much easier to simply say, okay, for my load balancers, here's the rules I want applied across this subscription. And then it will apply those in a much easier to manage and maintain way. And I find they're learning to be a little bit simpler too. Part of that might be because AWS was early on the scene and they built a bunch of stuff, and they have like tons of products, and it's great. And then Azure came in a little bit later and sort of applied like their Microsoft thinking to it, of how do we do the enterprisey thing and make it sort of useful to enterprise administrators. So you get some of that nice enterprise feeling, but it's not as mature as AWS in a lot of other ways. So it is tough, and there's fewer things to worry about in Azure, I've found. But that may not be the case as time goes forward, and both continue to expand and change. Like every time I come back and look at what Azure or AWS has changed in the last month, it's too much to even know like exactly what the changes are. So you have to sort of focus on the assets you care about, or have a team where each person can specialize, because there's just so much stuff out there. And I've worked in companies where we used, like a big chunk of, for instance, what AWS offers. And someone would ask me, hey, I'm using this AWS service. What should I worry about from a security perspective? And I'd say, I have no idea. I got to go read all their documents and figure out how it works. And then in 2 months, they're going to change something, and I'll be behind the times. So you really need people that can focus on those, some subset of assets you care about, and know how to secure them really well.
Yes. All right. Well, thank you so much for coming on the show.
Good talking to you.
All right, if you'd like to learn more about some of the cool research Charlie's up to, and to follow him in general, he's at Charlie Belmer on Twitter, and I definitely recommend checking out his blog at nullsweep.com. Thanks again for joining me this week. If you have any feedback, I'd love to hear from you. I'm at Jamus, JAMUSC on Twitter. And if you're part of a security team that needs visibility into your clients, employees, or third-party suppliers' breach credentials before criminals exploit them, then head over to breachsense.io to apply for a free 7-day trial. That's it for this week, and I'll be back in your earbuds next Thursday afternoon.